Welcome to homework.
Okay, so you've got a Lineweaver-Burk plot, and I'm not going to put the real numbers on here, but suffice it to say, you've got the plot that does not have the inhibitor, and you've got the plot that represents when you had an inhibitor. Okay, and what you're asked to do first is estimate the Vmax and the Km of the enzyme in the presence and absence of the inhibitor, right? So how do you do this? Well, recall that the slope is always going to be Km over Vmax. Okay, I guess it's going to help to say this is 1 over S, right? Substrate concentration, and so this is been expressed in inverse millimoles, right? Whereas your y-axis is in 1 over V naught units, right? So that's minutes per millimole. Okay. Okay. That's going to be important. Okay. So the important things here. Slope is always going to give you Km over Vmax. The y-intercept is always going to give you 1 over Vmax, right? And the x-intercept is going to give you negative 1 over Km. Okay, so you've been asked to find Vmax and Km, right? Well, so if we want to let's do Vmax first, right? It's just the y-intercept, right? So when I look at the plot, I see that the y-intercept is about 2 for the inhibited and about 4.6. Sorry, 2 for the uninhibited and 4.6 for the inhibited, right? So Vmax, so let's say 2 equals 1 over Vmax, which implies that Vmax equals 1 over 2, right? And the units then, if 2 was in units of millimoles inverse, then Vmax is going to be in units of just millimoles, right? So 1/2 millimole. Okay, we can do the same for the inhibited. Vmax equals 1 over 4.6 millimole. Okay, type this in my calculator. 1 divided by 4.6, I get 0.217. Okay. The wrong units, right? These are millimole minutes per minute. Okay, now we got the right units. Okay, and to do the same for Km, right? In each case, when I look at the x-intercept, that looks to be about negative 0.49, right? And remember, Km is the same for both of them, right? They both intersect the x-axis at the same point. Okay, so let's 0.49, negative 0.49 equals negative 1 over Km, and that this implies that Km equals 1 over 0.49, be slightly larger than 2. .04, let's say. Right, and the units here were millimole, right, inverse, which implies that the units of Km is going to be millimolar. Okay, what type of inhibition is displayed by this inhibitor? Explain the rationale behind your answer, right? Well, there are 3 types of inhibition, right? We've got competitive, uncompetitive, or non-competitive, right? Well, what can we learn when we look at our graph about what kind of inhibition we have? Well, the information we have is that 1 over Vmax is higher, which means Vmax went down. Vmax decreased, okay? And what happened to Km? Km stayed the same, right? Vmax decreased, okay? But Kmax stayed the same, okay? So that's non-competitive inhibition, just by definition. Non-competitive. Because Vmax decreased and Km did not. Or you could say it stayed the same. Okay. The final question then is, if the inhibitor concentration is 6 nanomolar, what is the inhibitor dissociation constant, Ki? Indicate the formula used and show only the key steps of the calculation. Okay, and the equation that we're going to need to solve this is the following. The Vmax apparent, right? That's like once the inhibition has started, right? So this is, I guess I could put this in red, right? Because what did we use for inhibited? We used blue for being inhibited and red for not being inhibited. It's kind of backwards, but okay. So Vmax blue, the inhibited one, is equal to, and then we say Vmax uninhibited, okay, over 1 plus I over Ki. Okay. That's basically all we have to worry about. So we can just do a little bit of algebra. We're going to get 1 plus I over Ki equals Vmax. Let's do you could also say Vmax and then Vm app. This means Vmax apparent with inhibition. If you're not using multiple colors, you're going to need to differentiate between these two, right? So maybe I'll do that here. Ooh. Okay. And then we can just subtract 1 from each side. Great. Right. And we want Ki. Okay. And at this point, we can just plug everything in. Right, so I, we said, is 6 nanomolar. Okay. Vmax and Vmap. We said we got 0.5 over 0.217. Minus 1. Okay, we got 6 divided by, I got 0.5 divided by 0.217 minus 1, and I get 4.6007. So let's just call this 4.6, right? And this is sort of, it's nanomolar over millimolar, sort of, but this does not have moles, right? So it's not just going to be 4.6. The point is that it's nano over milli, or it is just, it's, wait, no, because these units cancel. Sorry. Yeah. Okay. There you are.